Hello my people, video 2 on trig functions of any angle. This one specifically just has to do with reference angles. So let's take a look at it real quick. It says find the reference angle theta prime and sketch theta and theta prime in standard position. Okay. So we have 7 pi over 6. Oh, huh. I think I misinterpreted those instructions in what I misinterpreted those instructions in during the class time. I think that there's something different, but we'll get to that here in just a second. Now 7 pi over 6, if you remember, is right about there. Okay, because 6 pi over 6 would be pi, and then it's pi over 6 past 180, right? Past pi. Because if that's pi over 2, and that's pi, and that's 3 pi over 2, then that is about 7 pi over 6. And sort of that right there. This right here is theta prime. What I think that they're actually asking you to do here, that mythic they that come up with these math problems, sit in the darkened room in shadows. And so I think what they were asking you to do is then take this reference angle and put it back in, sorry, that's supposed to be theta, not theta prime, and put it back in that first quadrant, okay? Because basically what you're doing when you're dealing with the reference angle and the triangle that it gives you is you are basically taking this triangle and acting like it's this triangle and just adjusting positives and negatives for whatever quadrant you happen to be in, okay? All right, let's take a look at this next one. It says, okay, given negative 840 degrees, it says evaluate the sine, cosine, and tangent of the angle without using a calculator. Now, in order to do that, you need to recognize, well, first of all, that's more than 360. It's more than one time around. It's more than 720, so it's more than 2 times around. What we need to do is we need to figure out what 840 is coterminal with, okay? And so, you know, if you want to do it the lazy man's way, and that's fine for right now, we get negative 840, okay? And then we'll just add 360. That goes to negative 480. That goes to negative 120. Now you should be able to graph negative 120. And then on a positive side, it's at 240. Now this, of course, if we're dealing with degrees, is 180. This is 270. And basically, negative 840 is coterminal with positive 240, and positive 240 is 4 pi over 3, okay? And so it's roughly right about there, okay? And it creates this triangle of negative 1/2 and negative root 3 over 2, okay, in terms of the x and the y. So that basically negative 840 would go negatively around once. Here, I'll try to do it in a different color so it actually shows up. Negative 840 would be, I'm going to do it tight since I have to go around more than twice. Twice around, and then negative 120 degrees. Whereas when we're dealing with this coterminal of 240, we're just talking about less than a full revolution. So this would be your 240. Now, as I was explaining to those who were in class, you have to be very careful, because this is not saying that negative 840 is equal to positive 240, okay? That is not what it is saying. What it is saying is negative 840 and positive 240 have the same terminal side, have the same reference angle, create the same triangle, and have the same trig ratios. But having the same trig ratios is not the same thing as being the same angle. Because negative 240, that means that you've done more than 2 revolutions in a negative direction. Positive 240 means you've spun around less than a full revolution in a positive, okay? So those are not the same movement, okay? So it's just, since we use coterminals to find those trig ratios, it's just real easy to accidentally fall into that trap of thinking that because they have the same trig ratios that they must have that they must be the same angle, and that's just not the case. So sorry if I beat that drum just a little too hard, but I want to make sure that that's very, very clear. All right. Now, since we have this down here and we recognize that that's negative 1/2 negative root 3 over 2 if we're on the unit circle, I know that that means my cosine ratio is negative 1/2, my sine ratio is negative root 3 over 2, and tangent, of course, is sine over cosine positive root 3. Okay, let's do one of the same, but let's do it with radian measures. Now, negative 23 pi over 4. Now, in order to get this coterminal, we are going to need to add 2 pi, okay? And when you add 8 pi to 8 pi over 4 to negative 23 pi over 4, you're going to get negative 15 pi over 4. And then we add 8, no, and this is not equal. Let's put an arrow instead, right? I just got done telling you that it's not the same thing. And this winds up being negative 7 pi over 4. And then let's go ahead and just add 8 pi over 4 one more time, and we get pi over 4. Fantastic, okay? And so that is right here. Now, negative 23 pi over 4 is just shy of negative 24 pi over 4, which would, of course, would reduce to negative 6 pi. And negative 6 pi is almost a full 3 revolutions in the negative direction. So if you want to know what negative 23 pi over 4 looks like, you go once around, twice around, and back, okay? Now, just because it's coterminal with pi over 4 doesn't mean it's the same, right? It simply means that they have the same terminal side, they create the same reference angle, they therefore create the same triangle, and have the same trig ratios. Pi over 4 ought to be really easy. Root 2 over 2, root 2 over 2, and 1. Fantastic. Alrighty, let's go ahead and look a little bit more. In the next couple of problems, we're going to be getting, not all the way there, but towards what is known as inverse trig, right? You take, and we discussed in this first one, trigonometry is what we use to take angle measurements, sort of aroundness, and translate it into up and down and back and forth, right? Ratios of sides. So inverse trig is being given a ratio and trying to discern from the information what corresponding angle measurement it represents. So, I mean, you can understand how if you have two ways of thinking about measuring things, one that is around and out, and another is back and forth and up and down, you don't need one translation. You don't need a translation going one way. You need translations going both ways. Trig takes us from radius and theta measurement, angle measurement, over to back and forth and up and down. And inverse trig takes us from those ratios back to the theta measurement, and sometimes also to the radius. And that's kind of what we're getting at here. You notice that it says secant theta is equal to negative 9/4. Now, secant theta is one of those new ones that you don't see in geometry, but you pick up when you get to trig, when you get to pre-cal. Well, here's the thing. Secant, cosecant, and cotangent, I don't really care if you want to go ahead and regularly translate those and think about them in terms of what they're saying about sine, cosine, and tangent. And in fact, when you're dealing with them in the context of the unit circle, you kind of have to do that, right? You kind of have to know that cosine theta as a result is negative 4/9. Now remember, cosine ratios represent horizontal displacement, right? The x measurement. Now this, I'm going to kind of eyeball it, that is negative 1/2. Now negative 4/9 is just shy of that, right? And so what we're going to do is, okay, well if you have an x measurement, an x displacement of negative 4/9, that gets you to here, right? Well, that is the x displacement, that is the cosine measurement for two different angles. You know, it's for this angle right here, okay, and this angle right here. So which one is it? Well, you've been given an indication which one they want you to focus on, okay? It's this one right here. That's the one that they want you to focus on. So we'll go ahead and we'll take, you know, color it so that we're focused on the right thing. Now, basically that whole thing is tangent, but we're going to go ahead and use theta prime as sort of, you know, like I said, I think it was in the last video, not a substitute, more of a surrogate, right? And it kind of helps you to sort of get along. Now, remember that just because I charted this as negative 4/9, remember that this isn't necessarily the unit circle. If it is the unit circle, this is about negative 4/9. If this is not the unit circle, then that is negative 4/9 of whatever the radius measurement is, right? Because everything would be proportional. But instead of putting negative 4/9 and then trying to find something here, let's talk about negative 4/9. All right, let's go ahead and zoom in so you can see those numbers a little bit better. All right, well, that means that we need to go ahead and figure out what the y measurement is, okay, what that vertical displacement is from here to here. Now, that's 81, okay? That's going to be 16 when they're both squared. 81 minus 16 is 81 minus 6, 75, minus 10, 65. So this is going to be square root of 65, right? Well, almost. It needs to be negative square root of 65. So it's just a little bit longer than 8. Okay, so you're not, you know, you're close to having a Pythagorean triple right here because that's really, really close to a perfect square. It's just not quite there. Now, what you need from here is, it's not asking for all 6. It's not even asking for 3. It's simply asking for your tangent. And my tangent is going to be my opposite. Oh, whew. Thankfully, my radical is going to be in the numerator, so I will not have to rationalize it. Over negative 4. We'll go ahead and cancel out those negatives, and what we have is a tangent ratio of root 65 over 4. And since root 65 is a little more than 8, root 65 over 4 is just a wee bit more than 2. Okay? Now, let's go ahead and look at the next one, and this is going to get us even closer to formally talking about inverse trig. Now, find two solutions of the equation. Okay, we're going to first do this one right here, and then we're going to do that one. Now, sine theta, and we've just been talking about this, sine theta represents the vertical displacement, the y measurement, okay? If this is a unit circle, and if we eyeball it, that's about 1/2, right? And 1/2 on the sine represents two angles. Sine can be 1/2 if it's this theta. It can also be 1/2 if it's that theta. So let's go ahead and draw those angles. I'll draw the rays representing those angles. Okay, so there's a little bit of ambiguity there. If you're just given sine theta is equal to 1/2, what you're really being asked is, for what theta value is the sine ratio 1/2? Well, it's true for both of these. You know, it's true for this angle, and it's true for that angle. Okay, well, good that it's asking for two solutions. We'll just give them both. Now remember that if sine is 1/2, we recognize that. That's a unit circle value, right? When sine is 1/2, it's basically when theta is at pi over 6, or when theta is at 5 pi over 6. Okay, so that's true for that. Let's go ahead and do it for negative 1/2 because the same logic happens. Negative 1/2 is down here. We're going to go ahead and draw a line straight across and recognize that sine theta could be negative 1/2 for this point and that point, right? It could be negative 1/2 for this angle. It could be negative 1/2 for this angle, all right? Well, I'm sure you've pretty much figured out that this is going to be 7 pi over 6, and this is 11 pi over 6. So that is true for there. Okay, well, here's the thing. We made sure to keep our theta measurements between 0 and 2 pi, but it also asked us for 0 to 60, okay? And basically, that's just converting or just recognizing them from here. That's 30 degrees. That's 150 degrees. That's 210 degrees. And this right here is going to be 330 degrees, okay? And those are going, sorry, I should have done these two in red, but you get the point, okay? Now, and the reason I wanted to do it this way is I wanted to impress upon you that, especially for those of you that are visual thinkers, okay? If you're a visual thinker, this method of sort of in your mind, even if only in your mind's eye, thinking through the process of inverse trig is going to be very, very helpful. This is the way that I did it because I'm kind of a visual person. That's the way I always envisioned it when I was dealing with those things. Now, tangent is equal to root 3. Okay, well, here's the thing. It's a little bit more difficult to use the unit circle when it's not sine or cosine, but it's still possible, okay? And here's how. If tangent is equal to theta, then sine theta over cosine theta is equal to root 3, right? Which, if you've done any amount of trig and you've played with the unit circle, you recognize the fact that that could have come from that. So when you're saying tangent theta is equal to root 3, you're really saying where sine theta is equal to root 3 over 2 and cosine theta is equal to 1/2. Okay, well, I know where that is. Cosine is 1/2 here. Okay, and we'll go ahead and we'll go up to it right here. And we know that that's pi over 3. That's pi over 3. But we also know that positive root 3 could have come from negative root 3 over 2 and negative 1/2, which of course would be the same triangle just down here in the third quadrant. Okay, and like I said in class, this is sort of your first intimation as to why tangent has a different period. And I didn't eyeball that perfectly, but let's go ahead and extend it from the other ray so that at least it's consistent. Okay, so we'll sort of bend it there. Okay, this is 4 pi over 3. Both of those satisfy this right here. So theta is equal to pi over 3 and 4 pi over 3. You got a positive tangent ratio when they were both positive, and you got a positive tangent ratio when they were both negative. Now, the same thing can be said for this, right? Because you basically get sine theta over cosine theta is equal to negative root 3 over 2 over positive 1/2, or positive root 3 over 2 over negative 1/2. Again, it's going to be the same triangle. It's going to be the same reference angle. It's just going to be in the same, it's going to be in the second and fourth. It's going to be in the second and fourth quadrant rather than the first and the third, okay? And we'll kind of fudge it. I'm not doing it precisely to scale, right? And so this is 2 pi over 3 and 5 pi over 3. And basically, that's how you can reason it out if you're dealing with tangent and you're dealing with the unit circle. As long as it's a recognizable, quantity and it looks like something that has been reduced, right? Because here's the thing, you've reduced root 3 over 2 over 1/2 to root 3 before, right? And you could probably do the same thing, you know, if you were given instead tangent theta is equal to root 3 over 3. As long as you recognize the fact that originally that was 1 over root 3, and that comes from a reducing of that, which is, of course, instead of being at the pi over 3 ranges, that's at the pi over 6 and 5 pi over 6, 7 pi over 6, and 11 pi over 6, first and third quadrant for when it's positive, second, fourth quadrant for when it's negative. Now, remember that we have to follow the instructions. It asks for it not only in radians but degrees, and we know that pi over 3 is 60 degrees, and we know that 4 pi over 3 is going to be what? Gosh, I'm totally blanking. 240. And we know that 2 pi over 3 is going to be 120 degrees, and then 5 pi over 3 is, of course, 300. Now, it's kind of nice because they're exactly opposite, and therefore they're always going to be 180 degrees or pi beyond the other one, okay? Now, I'm hoping that that's kind of helpful. This is the way that I have taught inverse trig, especially to those students who were really visual people, and it becomes sort of a nice way of just at least kind of going over to the margin of your paper and checking your answer if they aren't coming, if those unit circle values just aren't coming to you really quickly on any particular day. That's it. I thought we were probably going to do 3 videos, but it turns out to be only 2 on this one. If you need more, obviously, I will provide more, but I'm hopeful that the video from our time in class today on top of these 2 will be sufficient, especially since this is merely an amplification of the previous section, 4.3, and what we did yesterday. Yeah, if you have any questions, please do let me know. Shoot me a message. I like the messages on Teams more than I like the emails, but I'll answer them either way. I'll be checking both. Bye.